Section 7.4.21, a certain flight arrives on time 80% of the time. Suppose 100 flights are randomly selected. Use the normal approximation to find the binomial to approximate the probability for the following. So we want to first approximate exactly 85 flights are on time. Before we do that, we want to be able to find the mean of the values of x. Okay, so what that's going to equal, it's going to equal n times p. Okay, and so therefore n, which is the amount of flights, which is equal to 100, and we're going to multiply it by the probability. Well, the probability is 80%, so we're going to write that as 0.80, and so therefore we end up getting 80. Okay, so therefore we know that the mean there of the binomial is 80. Okay, and then we want to find the standard deviation. So the formula for the standard deviation is taking the value of NP, and then we're going to multiply that by 1 minus P. So what that's going to equal is, we know that what N times P equals, well, we know that that's equal to 80. And that's going to be 1 minus 0.80. And so if we take the square root of that number, we end up getting 4. So therefore, there is our standard deviation. Okay, so now what we want to do is we want to find out exactly 85 flights that are on time. So what it's asking us to do is we want to approximate P of 85. Okay, and so first we have to adjust for continuity by determining an interval of width 1 centered about x. So that means what we're looking for is we want to find the probability of 85 to be approximately the following. So we're going to have 0.5, 85 minus 0.5, which gives us 84.5. And then 85 plus 0.5 is 85.5. So when we graph this on our bell curve, okay, what that says is that we want to be able to use the mean, which is at 80. And what we want to find is we want to find the area that's in between 84.5 and 85.5. So we're looking for that area. Okay, and so what we're going to have to do is we need to convert our values into z-scores. So if we know that x is equal to 84.5, we're going to find the z-score. We're going to call it z1. And we know what the formula is. The formula is to take the value of x, which is 84.5. We're going to subtract the mean that we got in the first part, which is 80. And then we're going to divide it by the standard deviation of 4. So therefore, z1 is going to be approximately, rounded to 2 decimal places, 1.13. Okay, and then if we let x equal 85.5, then our second z-score is going to equal 85.5 minus 80 divided by 4. And so therefore, the second z-score is going to be approximately 1.38. Okay, so now when we graph this, okay, we know that we have a now standard normal distribution. Where now our z-score, z1, is going to equal 1.13, and our other z-score is going to be 1.38. And so we want to find the area that's in between there. So what we want to be able to do is we want to find the probability of z being in between 1.13 and 1.38. So what we want to be able to find is we're going to take the probability of z being less than 1.38 minus the probability of z being less than 1.13. Okay. So now, using your table of z-scores, you can get 0.9162 and then subtract the area to the left of 1.13, which is 0.8708, which gives us an area of 0.0454. So therefore, we can say that the probability that exactly 85 of the 100 flights are on time is approximately 0.0454. Okay, so if I wanted to be able to use the calculator, again, what we're going to do is we're going to go to the calculator here. Okay, what we're going to do is we're going to select second distribution. We're going to go to normal CDF. Okay, and so we're looking for the area in between. So the lower bound is 1.13. The upper bound is 1.38. We know that our mean is 0 and our standard deviation is 1. And so therefore there we get our 0. For the following. So that gives the same area here. Okay, and then if we wanted to use statcrunch, then we can go to stat and then calculators and go to normal. Okay, we want to find the areas that are in between. We know our mean is 0, our standard deviation is 1. We have 1.13 as our lower bound. We have 1.38 as our upper bound, and therefore it computes. And so therefore we get our area again of rounding it to 4 decimal places. So therefore there it is on statcrunch. Okay, the next example, we want to find at least 85 flights are on time. So whenever we talk about at least, okay, we know that we're dealing with greater than or equal to. So technically we're looking for the probability that x is going to be greater than or equal to 85. Okay, so if we want to look for the probability that x is greater than or equal to 85, then what we're looking for is approximately where the probability of x is going to be greater than 84.5. Okay, so what we can do is that we know that our bell curve is the following. Okay, so we know that we have a value of 80 as our mean. Okay, and we know that our x value represents 84.5, and we want to find the area to the right of that. Okay, so what we can do now is we need to find the z-score for 84.5, which we already did. So we know that the z-score, again, so we can do this, was 84.5 minus 80 over 4, and therefore z gave us 1.13. So now when we write our bell curve, we know that we have a mean of 0, and now the z-score that we're using is going to be 1.13, and we want to find the area to the right of that. Okay, so if we want to find the area to the right of that, then what we're looking for is the probability that z is greater than 1.13. So if we take a look at that on our table, okay, we're going to take 1 and then subtract everything that's to the left of that. And so the area to the left of that is, let's go ahead and let me write that here. So the area to the left means we need to take 1 and subtract the area to the left, which is 0.8708 that you can find on the table. and therefore that gives us 0.1292 as our area. And so therefore we can say that the probability that at least 85 of the 100 flights are on time is approximately 0.1292. Now, if we wanted to use a calculator, then what we would do is go to second distribution. Okay, we can go to normal CDF. Okay, we can use the lower bound as 1.13. We can use the upper bound as 9999 with a standard deviation of, a mean of 0 and a standard deviation of 1. And then we can hit enter, and therefore there is our same area that we just found by using the table. Now, if we want to use statcrunch, okay, let's go to our normal curve. Okay, we want to find the area that's greater than 1.13. We know our mean is 0 and we have our standard deviation of 1. So we're going to select greater than, and we're going to put 1.13 and then select compute, and then we're going to get the same area there. So therefore there is our area using statcrunch. So either or, you can use either three of those scenarios to find your probability. Okay, now what we want to find is where it's fewer than 75 flights are on time. So fewer, what does fewer mean? Well, that means that we want to find the probability that x is going to be less than 75. So what we're looking for is the probability that x is going to be less than 74.5. So again, what we're looking for, we have our bell curve. Okay, we know that our mean is 80. We know that we're looking for 74.5, and we're looking for the area that's to the left of that. So what we want to do is we want to find the z-score. So in order to find the z-score, we know that our x value is 74.5. We're subtracting the mean of 80 from our beginning of the problem, divided by the standard deviation, which is 4. And so what we get is negative 1.38. So therefore, on our bell curve now, once we convert it to a z-score, we know that our mean is 0, and now our z-score is at negative 1.38, and we want to find the area that's to the left of that. So, again, finding the probability that the z-score is less than negative 1.38. If we go to our table, then what we end up getting is 0.0838. Okay, and let's see how that we do this on the calculator. Again, if we take second distribution, normal CDF, our lower bound is going to be negative 9999. Our upper bound is going to be negative 1.38. We know our mean is 0 and our standard deviation is 1. So we get the same thing rounded to 4 decimal places. And if we wanted to use the calculator here on statcrunch, we're going to set the inequality to be less than, because we want to find it to be less than, and less than negative 1.38. And let's compute, and then we end up getting the same result with the actual graph of what we're looking for. And so therefore, that's how we would use statcrunch. So therefore, we can say that the probability that fewer than 75 of the 100 flights are on time is approximately 0.038. Okay, next we want to find between 75 and 90 that are on time. So what that means is we want to find the probability that x is going to be in between 75 and 90. But again, we want to find an approximation, so we need to go 0.5 smaller and 0.5 larger. So that means we're finding the probability of 74.5 and 90.5. Okay, so when we look at our bell curve, we know that our mean right now is 80, and we want to find the area that's in between 74.5 and 90.5. So we need to find a z-score. So z1 is going to equal 74.5 minus 80 over 4. So z1 rounded to 2 decimal places is going to be negative 1.38. Then we're going to find z2, which is going to equal 90.5 minus 80 divided by 4. So the second z-score is going to be 2.63. So that means when we convert it to z-scores, then now our mean is going to be 0, and our z-scores are now going to be in between negative 1.38 and 2.63, and we want to find the area that's in between. So what we want to be able to do is we want to find the probability that z is going to be in between negative 1.38 and 2.63, which is the same as taking the probability of z being less than or equal to 2.63 and then subtracting the area of z being less than or equal to negative 1.38. So again, if we use our table, we're going to get the area that's to the left of 2.63 to be 0.9957, and then we're going to subtract the area to the left of negative 1.38, which is 0.0838, which then gives us an area of 0.9119. So if we wanted to use our calculator, again, we're going to go to second distribution, and we're going to go to normal CDF. We know our lower z-score is negative 1.38. The upper z-score is 2.63. We know that our mean is 0, our standard deviation is 1, and then we hit enter, and then therefore there is our area when we're using the TI-84 calculator. Okay, and now let's use statcrunch. So we want to find the area that's in between, so we want to select between. And we know that our mean is 0, our standard deviation is 1. So our lower number is negative 1.38, which is our z-score there. Higher is 2.63, and then we're going to select compute. And so therefore there is our graph on statcrunch that gives us the following areas. So then what we can say is that the probability that 75 to 90 of the 100 flights are on time is approximately 0.9119.